So all that being said, that brings us to the Clarity language itself. So Clarity is a Lisp-like language, like I said, built specifically for the Stacks blockchain with properties designed to prevent exploitation. So much like Bitcoin has an ethos of being trustless, right, or not relying on outside sources, Clarity has taken into account the reality of human error and developer error and addresses it at a language level. So first one, no reentrancy. I just mentioned the DAO hack, which was caused by a bug all around this concept of reentrancy. So put simply, reentrancy is when one contract can call into another contract before it has finished executing. And this can easily start a pattern where one action is executed before another one has completed. This is not allowed at the language level in Clarity. So contracts written in Clarity just simply do not have the functionality to do this. So there's no recursiveness, there's no loops, which you could make the argument that these kind of functionalities just shouldn't be available in a smart contract to begin with, right? And you can still, there is iteration, right? So you can't iterate over like a list of elements. They have to be predefined, right? So you can't have like an infinite loop going. And we'll look at more examples of that as we actually start writing some contracts here. Clarity is interpreted, not compiled. So this means that it's human readable directly from the chain. So any code that you write in a contract, when you deploy it to the chain, it is immediately human readable, right? It's not compiled to bytecode, it's just as is. Now, I want to note here that this doesn't mean that code written in compiled languages can't be read by humans after they've been deployed. So Solidity, for example, if anybody has ever worked with that, there is a service called Etherscan that allows you to read Ethereum contracts. So it is possible. The big difference here is that Etherscan is a third-party service, right? It's not part of the language itself. So we're, again, going back to the trustless, the idea of being trustless. With that, you're relying on an outside source to, compile, to turn the code back from bytecode to actual human readable code. Whereas Clarity is just, this is written into the language itself, right? Decidable. So from the code, you can know with certainty what the program will do. Guarantee the program execution will end. So this is tied back to a slightly more theoretical concept in computer science called the halting problem. And the halting problem basically presents this problem of determining from a program and its input whether the program will finish running or continue to run forever, right? And that's actually a pretty cool concept. It's outside the scope of what we're doing here, so I'm not going to get into it or anything, but if you're curious about it, I recommend looking it up because it is pretty cool. But basically, in theory, a decidable language gives us certainty about what the program will do before we actually run it. And with this comes an accurate picture of gas costs before execution. If you, for example, if you've ever used Stacks, like a Hero wallet, for example, to run a transaction, you can see that you can select from set fee amounts when you're calling a transaction, versus if you've used MetaMask, for example, you might have noticed that when you call a transaction, you're given an estimated gas fee, which you don't actually see what it is until you've called it and run it, right? So this is because of the decidable aspect of Clarity language, that it allows us to know ahead of time how much a transaction is going to cost, right? Or I should say, it lets us know the maximum amount of gas that a transaction could cost, right? It could be a little bit less, but it will be up to this X amount. Allows for post conditions. So these are attached to transactions to assert the chain state has changed in a specific way. So basically, when building full stack apps, we can write into the JavaScript on the client side that once a transaction has completed, these specific things should have happened. And if anything else has happened, the transaction should be aborted. In the event that a transaction aborts because of these post conditions, then the user only has to pay the transaction fee. So quick example of post condition flow. We can see here that Alice is making a contract call and she is transferring an NFT, right? So she makes the call, the transaction runs, and then the post conditions come in and they say, did the ownership of an NFT with this specific ID change from the sender to this specified address? If this is true, then we'll materialize the changes and everybody's happy, we move on. If no, then the entire transaction gets reverted. We will be looking at post conditions in depth in a later session. Okay, moving on with some more of the properties here. It guards against overflows and underflows. So what this means is that if a function in your contract generates a number that is too big or too small for the language to handle, it will automatically abort. Custom tokens built in. So tokens are first-class citizens in Clarity. So there are built-in functions to create your own fungible tokens and non-fungible tokens for stacks, rather than needing to create that functionality in a separate interface. Responses cannot be left unchecked. You cannot write a function without handling a return response. So rather than it being up to the developers to ensure that they handle responses in a proper way, the language itself has checks in place to ensure that these are handled. So for example, if a developer is working on a contract and somewhere along, you've got a whole bunch of functions that you're writing, and somewhere along the line you forget to handle a response, Clarity itself will tell you that there's an error here, that this response needs to be checked or handled, and it won't let you move forward until you do so. So these are some of the main properties of the Clarity language that kind of set it apart from other languages. Clarity is fundamentally written to be transparent, secure, and trustless. Again, keeping in line with the principles of Bitcoin, which kind of makes sense, right? Because Stacks has itself has this kind of connection to Bitcoin in which we want to use the security and the all the benefits that we have from Bitcoin and kind of pull that out to create these applications on Web3. So I think that this is what makes smart contracts on Clarity really, really powerful within the Web3 space right now. Okay, so now moving away from the language properties to some of the tools that are available for you guys. First one is the Clarity Repl. So we won't be using this much. Maybe we'll touch on it, but not really. We won't really be using the Repl itself throughout this course, but some developers like to use the Repl directly. So this is available for you. So basically, a Repl is an interactive programming environment, right, that takes your inputs, evaluates them, and returns the results. If you guys want to use the Repl directly, we can drop the the resource to get that installed.